Hey, what's going on, guys? Let's do this problem right here. The question is asking what is the force on a 2-meter long segment of a wire carrying a current of 15 ampere perpendicular to a 1.2 Tesla strong magnetic field. So the question is asking for the force. Let's see how we can find it. So first of all, let's draw a diagram for this one. So let's draw the magnetic field perpendicular. So let's draw like this. So if we have magnetic field going in this direction, we are going to have current going perpendicular to this. So perpendicular to this, a wire goes through this and the current is given by 15 ampere. So I is equal to 15 ampere. Also they have given the length of this wire, that is 2 meter, right? 2 meters is the length. So 2 meter. Let's see what else we have. And these are the information we have, and also they have given the magnetic field. And let's see what's going to be the direction of this force. Since this ampere is going in this direction, you have to do your right hand method. So if you keep right hand like this and fold it in this magnetic field's direction. So if you fold like this, your thumb is going to come outside, right? It's going to point outside. So the direction of the force is going to be outside. So we put dot for outside. So this is going to be the force's direction. Now the question is asking to find the force. For force for one charge, we use this equation, that is QVB sine theta. Since if you notice the direction of the particle and the force is perpendicular to each other, this is going to be 1 because 90 degree, right? So this is 1, so we can cancel this one and write QVB. So this is for one charge. This equation is for one charge. Now we have to find it for all the charges. So force for all charges is equal to number of charges, that is capital N QVB. So this is going to be the force of all charges. Now if you notice, we don't have the charge that is provided, we don't have the velocity provided, we have the Tesla, that is B, and we don't have the number of charges too. So let's see how we can cancel this and rearrange in a different way. So if you remember this, we have V right here and Q. So another equation related to these values is drift velocity equation. If you remember the drift velocity equation, that's I is equal to NQVD, right? So here what we can do is we can replace this VD, if we can rearrange this VD and replace here. Actually this is NQVDA, right? So here let's rearrange this one. VD is going to be equal to I over NQA. Now let's replace this value with this one. Actually here this N is charges per meter cube, that we have to remember. Number of charges per meter cube, that is same as capital N, this capital N, number of charges per meter cube. So let's leave it like this for now and then put it here. So now let's plug this one. So this is going to be NQ. Now I am plugging this V instead of I over NQ A instead of V. So this is going to be I right here. B in the denominator we are going to have NQA, right? So this Q cancels and we have this N right here. We can rewrite this one as NIB over, this is number of charges per volume, So this is going to be, we can write this as N over V. This V is volume times A, right? So here this and cancels. This is 1 over volume. And here we have area. And if you notice, this length is provided right here. If I multiply this area by length, that's going to give us volume. But if I multiply length right here, I have to multiply numerator too. So this is equal to volume. So let's rewrite this one. So IBL over 1 over volume times volume, A times L volume. So here volume cancels, so we are left with IBL. So this is the equation we are going to use to find the force. So let's find the force. So F is equal to IBL. Now we have all the information. We have the charge that's provided 15 ampere times B magnetic field that's provided 1.2 Tesla. So 1.2 Tesla times the length, that is 2 meter. 2 meter. So 15 times 2, 30. 30 times 1.2, that's going to give us 36 ampere Tesla meter. But we want this one in terms of Newton, right? So let's convert the units. 36 ampere Tesla is equal to Newton per ampere meter times meter. So here ampere cancels, meter cancels, we are left with Newton. So this is going to be 36 Newton, and that's going to be the force. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.